The notes for today are on Unit 1, Part 2 on solving inequalities. So you have seen inequalities before. We've talked about them with comparing and ordering numbers. And an inequality, just to kind of start off, is a mathematical sentence connecting an expression to a value, a variable, or another expression with an inequality sign. So that's the main thing that makes it an inequality. It has that inequality symbol. So just to kind of review, we have our greater than symbol. We have our greater than or equal to. So if it has a line under there, it could be equal to that number. We have our less than symbol, and we have less than or equal to. So again, the line underneath means that it could be equal to. And then we have the not equal to is the equal sign with a slash through it. But think about what we've done in the past. You know, your inequality symbol, think of it as like an alligator, Pac-Man is going to eat what is bigger. So here are a couple of examples of inequalities. Notice that they all have an inequality symbol. So it doesn't matter how crazy they look, they have some kind of inequality symbol going on. So what we're going to do to start is we're going to do some basics here. We're going to check to make sure a solution works for an inequality. So unlike equations, inequalities have more than one solution, more than one answer. You can check whether a value such as x equals 6 is a solution to an inequality, the same way you would check if it is a solution to an equation. You'd substitute it in and see if it is true. So we're going to do that with starting with problem 2. It says, is m equals 11 a solution set to 4m plus 30 is less than or equal to 70? So what we're going to do is we're going to take our 11 and we are going to substitute that in for m. Because it's 4m, that means 4 times m, or 4 times 11. So we're going to do our 4 times 11 plus 30 is less than or equal to 70. We want to see if that is true. So if we do the 4 times 11, that becomes 44 plus 30, which if we put that together is 74, and 74 is not less than or equal to 70. So this is a no. It is not part of the solution set. So we're checking to see, okay, when plugged in, does it make sense? Does it work out? And then it's kind of just a yes or no question from that point. All right, number 3, is m equals 10 a solution? So now we're looking at 10 to the same inequality, 4m plus 30 is less than or equal to 70. So we're going to replace 4m. So we're going to do 4 times 10, which is 40, plus 30. And we want to see, is it less than or equal to 70? So that becomes 70 is less than or equal to 70. Because it is less than or equal to, has that bar underneath, this is a yes. It can be a solution. If it was 70 is less than 70, then it would be a no. But because it has less than or equal to, it is definitely going to be a yes. All right, number 4, we are now going to throw in an ordered pair. So just to recap, the first number is x, the second number is y. So we are going to plug that into our inequality here. So wherever we have x, we're going to have a 7. Wherever we have y, we're going to plug in a 1. And then we want to see, does that make it a true statement or not? So we plugged in 7 plus 3 times 1, so that would be 10. And we have 10 is less than 10. Because it's 10 is less than 10, not less than or equal to, this is a no. It is not part of the solution. The last one, number 5. Same thing. We have our x and our y. So x is 2, y is 8. We're going to plug it back into this inequality now. And we want to keep in mind that the first thing is y. A lot of times people see that first digit and they automatically think it's the first one in the ordered pair, but it's not. So we're going to plug in our y, which is 8. We're going to have our symbol. We're going to have our x, which is 2 plus 9. So it says 8 is greater than 11. Well, 8 isn't bigger than 11. So this is also going to be a no. So to check, you're just plugging it back in, seeing if it works out. If it does, it's a yes. If it doesn't, it is a no. Okay, we are going to bypass problem 6, and we are going to jump into solving with graphing. And we're actually going to jump all the way down to problem 7. So we're looking at 7, 8, 9, and 10. So when you go to solve inequalities, it is very much like solving an equation. You are going to start and you are going to draw a line down your inequality symbol, just like you would an equal sign. And our goal is to get that letter, that X, by itself, just like we did with equations. So what we're going to do to start is we're going to subtract 10 from both sides. So we have our 9x, we have our greater than symbol, and we have -9, just like an equation. Still need to get X alone, so we're going to divide both sides by 9. So we have X is greater than -1. Okay, so that part is part of our answer, so I'm going to box that. And then the next part is that we are going to show this on our number line. So remember, there's more than one answer. So really the answer is any number greater than -1. So what we're going to do to show that on our number line is we're going to put a point at -1. And because that is a greater than symbol, it is an open point because -1 is not included. X is bigger than -1. So now we got to figure out, okay, is our arrow going left? Is our arrow going right? And to decide that, we're going to look at our symbol, which says X is greater. So greater, those values would be to the right. So we're going to draw our arrow to the right side. So again, it's an open point because it does not have that line underneath the inequality. So I'm going to make a note over here. If it's greater than or less than, it's an open dot. Greater than or equal to or less than or equal to, it is a closed dot. So if it has that line underneath, it is a closed point, closed dot. And then that's it. So you have your number line piece, you have your inequality, done. All right, problem 8, same deal. We're going to start by getting that X by itself. So we are going to subtract 8 from both sides. So we have 4x, we have our greater than symbol, and now we have -16. So again, solving for that X, we want that by itself. We're going to divide by 4. So X is greater than -4. All right, so we finished the inequality portion. Oh, that did not turn out the way I wanted it to. Sorry. Let me redo this. Oh, that's the same thing. All right. So we are going to graph it. So -4, it is an open point because we have this greater than symbol. So we're going to have our open point at -4, and then we need to decide which way we're going. So again, we're looking at the symbol. X is greater means that we are going to the right side. We want those values that are larger. So we're going to go that direction. Okay, we got 2 more to go. Number 9, we again want to start by getting X by itself. And we're going to start by subtracting 2. So remember that negative symbol there goes with the X. That's not in front of the 2. So we have -X is greater than or equal to +2. Okay, so now we got to get X by itself. And this is kind of like a -1 out there. So I'm going to divide both sides by -1. So there is something special that happens when we divide or multiply by a negative with inequalities. We're going to have our X, but now our symbol is changing direction. And 2 divided by -1 is -2. So you might want to make yourself a note. So when multiplying or dividing by a negative, you're going to switch the inequality symbol. And I apologize for my handwriting on the iPad. So when you multiply or divide by a negative, you are going to switch that inequality symbol every time. And this is where people make the biggest mistakes. They forget to do that. So this time we're going to have a point at -2, and it is going to be filled in because it's equal to, and its x is less than or equal to, which is going to be to the left. You can always check your answer too, just like our equations and absolute value inequalities. Take any number you want. Like let's say, let me change colors here. Let's say we take the same problem and you want to check to make sure you're right. If you would take like -4 and plug it back in, 2 minus -4, you want to make sure that that is greater than or equal to 4. Well, that will become 2 plus 4, which is 6, and 6 is greater than or equal to 4. So that means that that's in the solution, and that's why that arrow is going that direction, because all of those numbers in that arrow make that a true statement. Last one, number 10. Number 10 looks a little crazy because we have the fraction, but it is actually the same process that we've been doing. We're going to subtract 2 from both sides. So again, we want to get x by itself. So we have x divided by 4. Key term I just said was divide, is greater than 1. So now that we want to get x by itself, we have to undo dividing by 4, which is multiplying by 4. So we end up with x is greater, that symbol doesn't change because it's still positives, dividing by positive, or multiplying by positive, and 1 times 4 is 4. So we have x is greater than 4. So we'll have an open point because it's greater than, not greater than or equal to, and we'll have our arrow going to the right. And again, you can always check your answer by plugging in, something like maybe 5, plugging 5 back in and making sure that when you do all that in your calculator, you get something greater than 3. So it's always a great idea to check your answers. So just to recap, we have our inequality symbols here. And again, if it is greater than or less than, it's an open point. Greater than or equal to, less than or equal to are filled in points. And we solved inequalities just like we did equations. We got that x by itself, and then we added the piece of the number line with the graphing.